The wind was howling at 35 miles per hour across the Montana training range when Sergeant Loisa Brock stepped up to the 800-yard line. Every sniper in her unit had already failed the shot. The crosswind was so brutal that even the most experienced marksmen couldn't compensate for the bullet's drift. But Loisa had something to prove. 6 months earlier, these same soldiers had laughed when she miscalculated a simple 10-mile-per-hour breeze during basic training. They called her Weathervane. Always spinning, never accurate. What they didn't know was that failure would drive her to master something no one thought possible, reading wind patterns like a meteorologist and making shots that defied physics itself. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. Staff Sergeant Loisa Brock pressed her eye against the rifle scope, her hands trembling slightly as she tried to steady her breathing on the windswept range at Fort Carson, Colorado. The morning air carried the distinct bite of early autumn, and the tall grass around the shooting positions swayed in unpredictable patterns that made her stomach clench with familiar anxiety. She was supposed to be calculating wind speed and direction, adjusting her scope accordingly, and placing her shot within the center ring of a target 600 yards downrange. Instead, she was watching her bullet consistently drift wide, missing not by inches but by entire feet. "Brock, what's your wind call?" shouted Master Sergeant David Chen from behind the firing line, his voice carrying that edge of impatience that had become all too familiar over the past 3 months of advanced marksmanship training. Loisa pulled back from her scope, wiping sweat from her forehead despite the cool temperature. She studied the grass, watched the mirage waves rising from the heated earth, tried to feel the wind direction on her face the way the instructors had taught them. Everything looked chaotic, contradictory. The grass near the target seemed to be blowing left while the vegetation halfway downrange appeared to be moving right. The mirage patterns shifted constantly, offering no clear indication of what the bullet would encounter during its flight. "UH 10 miles per hour, left to right," she called back, knowing even as she said it that her assessment was probably wrong. "Are you asking me or telling me?" Chun's response was sharp. "Make your call and take your shot." Loisa adjusted her scope 2 clicks to the left, chambered around, and squeezed the trigger. The rifle bucked against her shoulder, and she watched through the scope as her bullet struck the dirt embankment 4 feet to the right of the target. Not even close. The silence that followed was worse than any criticism. Around her, the other soldiers in her advanced sniper training course continued their own shooting sequences, their bullets consistently finding the target zone, while hers seemed to follow some mysterious trajectory that had nothing to do with her scope adjustments. Private First Class Marcus Jefferson, shooting from the position next to hers, glanced over with barely concealed amusement. "Maybe try reading the wind instead of guessing," he muttered just loud enough for her to hear. This isn't basic training anymore. The comment stung because it was partially true. Loisa had excelled in most aspects of military training. She was an exceptional physical specimen, could navigate terrain better than most of her male counterparts, and had demonstrated tactical thinking that impressed her instructors. But when it came to long-range precision shooting, specifically the complex art of reading wind conditions and calculating their effects on bullet trajectory, she seemed to hit an impenetrable wall. The problem wasn't her shooting fundamentals. On calm days, when wind wasn't a factor, Loisa could place shots with remarkable consistency. Her breathing technique was textbook perfect, her trigger control was smooth and predictable, and her natural hand-eye coordination was actually above average. But the moment wind entered the equation, everything fell apart. Wind reading was considered one of the most difficult skills in precision shooting, requiring a combination of scientific understanding, intuitive feel, and experience that typically took years to develop. The best snipers could look at environmental indicators, grass movement, mirage patterns, dust particles in the air, even the way birds flew, and accurately estimate wind speed and direction at multiple points along a bullet's path. They understood that wind rarely blew uniformly from point A to point B, that it could be gusting from the left at the shooter's position while creating a crosswind from the right at the target, with completely different conditions in between. Loisa, these subtleties might as well have been written in a foreign language. She could memorize the theoretical formulas for wind drift calculation, understand the physics of how air resistance affected different bullet weights and velocities, and recite the proper procedures for reading environmental conditions. But when she stepped up to the firing line with real wind creating real challenges, her mind seemed to freeze. "Brock, you're overthinking it," Sergeant First Class Amanda Rodriguez had told her after a particularly frustrating training session the previous week. Rodriguez was one of the few female snipers in their unit and had taken an interest in Loisa's struggles. Wind reading isn't just about the science. There's an art to it, an intuitive component that you develop through experience. But experience was exactly what Loisa felt she couldn't get. Every missed shot in front of her peers chipped away at her confidence, making her second-guess every assessment, every scope adjustment, every trigger pull. She had started keeping a detailed notebook recording wind conditions, her estimates, and the actual results of her shots, hoping to find patterns that would help her improve. Instead, the data seemed to highlight just how inconsistent her wind reading abilities were. The worst part was the growing reputation she was developing within the unit. During their first week of training, when introductions were made and backgrounds shared, Loisa had mentioned her childhood in rural Nebraska, where her father had taken her hunting from a young age. Several soldiers had assumed this meant she would be a natural at reading wind conditions, given her supposed experience with outdoor shooting. When her struggles became apparent, the disappointment seemed magnified. "I thought farm girls were supposed to know about wind," Corporal Brian Mitchell had joked during the break between training exercises. "Isn't that like part of growing up in tornado country?" The comment had been meant as light teasing, but it highlighted something that bothered Loisa deeply. Her rural background was supposed to be an advantage, a foundation of practical experience that would translate into military success. Instead, she felt like she was failing to live up to expectations that she had never actually earned. The truth was that her hunting experience with her father had been limited to relatively short-range shooting in heavily wooded areas where wind was rarely a significant factor. The vast, open ranges of military training presented challenges she had never encountered as a civilian. The distances were longer, the wind patterns more complex, and the pressure to perform in front of trained observers was unlike anything she had experienced during casual hunting trips. As the training weeks progressed, Loisa found herself dreading wind-heavy days on the range. She would check weather reports obsessively, hoping for calm conditions that would allow her to demonstrate her other shooting skills without the complication of environmental factors. When windy conditions were unavoidable, she would arrive at the range with her stomach in knots, knowing that another day of missed shots and frustrated instructors awaited. The breaking point came during the fourth week of training, when their class was conducting a competitive exercise designed to simulate real-world sniping scenarios. Each student was required to engage multiple targets at varying distances under time pressure, with scoring based not just on accuracy, but on the speed of target acquisition and engagement. Wind conditions that day were particularly challenging, with gusts reaching 25 miles per hour and shifting direction unpredictably. Loisa's performance was disastrous. She missed her first 3 shots completely, spent too much time trying to read wind conditions between engagements, and finished the exercise with the lowest score in the class by a significant margin. As she cleared her weapon and prepared to leave the firing line, she could hear whispered conversations behind her. "She just can't read wind," someone said. Doesn't matter how good her other skills are if she can't hit anything when it's breezy. Maybe she should request transfer to a different specialty, another voice suggested. Not everyone's cut out for precision shooting. Walking back to the barracks that evening, Loisa felt a familiar weight settling in her chest. It was the same feeling she had experienced in high school when she struggled with advanced mathematics, despite excelling in other subjects. The sense that everyone around her possessed some innate ability that she simply lacked, that no amount of effort or study would allow her to overcome her natural limitations. But unlike high school mathematics, this wasn't just about grades or personal satisfaction. Her inability to master wind reading could have real consequences in combat situations. Snipers were expected to provide precise fire support for their units, often in challenging environmental conditions. If she couldn't reliably hit targets, when wind was a factor, she would be a liability rather than an asset. That night, lying in her bunk and staring at the ceiling, Loisa made a decision that would change everything. She wasn't going to accept that some people were just naturally good at reading wind while others weren't. There had to be a way to develop this skill through systematic study and practice, even if it meant approaching the problem differently than everyone else. She just had no idea that her quest to master wind reading would eventually lead her to attempt something that veteran snipers considered impossible, making an accurate shot in Crosswind so severe that they defied conventional calculation methods, or that her journey would transform her from the soldier who couldn't calculate a simple breeze into someone whose understanding of wind patterns would become the stuff of military legend. Preparing and narrating this story took us a lot of time. So if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The rumors started spreading through Fort Carson like wildfire after Loisa's catastrophic performance during the competitive exercise. By the time she entered the mess hall for dinner that Friday evening, conversations seemed to quiet as she passed, only to resume in hushed tones once she moved beyond earshot. She tried to convince herself it was paranoia, but the sideways glances and barely suppressed smirks told a different story. Specialist Tyler Brooks was the first to make the mockery public. During their Monday morning equipment inspection, as soldiers cleaned and organized their gear for the week's training, Brooks held up a small Weathervane he'd fashioned from spare metal parts in the motor pool. "Hey Brock," he called out across the equipment bay, his voice carrying clearly through the space. "I made you something to help with your wind reading problem." He spun the makeshift device with his finger, watching it turn aimlessly. "See, it spins around randomly, just like your shot groups." Laughter erupted from several soldiers nearby. Even some who hadn't been involved in the original joke couldn't help but chuckle at the crude but creative insult. Loisa felt her face flush red, but she forced herself to continue organizing her rifle cleaning kit without responding. Reacting would only make things worse, but Brooks wasn't finished. "Actually, wait," he said, pretending to reconsider. "This is too advanced for Brock. It might actually point in the right direction sometimes." The laughter grew louder, and Loisa noticed that even Sergeant Rodriguez, who had previously shown her support, was struggling to hide a smile. The betrayal stung more than the original joke. Over the following days, the Weathervane became a recurring symbol of her struggles. Brooks would place it on her equipment whenever she wasn't looking, or wave it dramatically during wind reading exercises. Other soldiers began contributing their own variations on the theme. Someone left a children's book about weather patterns in her locker. Another soldier started making exaggerated wind-checking gestures whenever she approached the firing line, licking his finger and holding it up to test air currents with theatrical seriousness. The nicknames multiplied beyond the original Weathervane. She became Gustbuster for her ability to miss targets regardless of wind conditions. Breeze Blind for her apparent inability to detect even obvious wind patterns. Stormfront because, as Private Jefferson put it, she creates disaster. wherever the wind is blowing. What made the situation particularly painful was how creative and persistent the mockery became. During their meteorology class, where snipers learned to read weather patterns and atmospheric conditions, Corporal Michelle Santos would loudly ask the instructor questions clearly designed to highlight Loisa's deficiencies. "Sir, what should you do if you literally can't tell which direction the wind is blowing?" Santos asked during one session, her tone innocent but her intent obvious. "Asking for a friend who might be sitting right behind me." The instructor, Staff Sergeant Kevin Walsh, seemed uncomfortable with the obvious targeting but answered professionally. "In that case, you'd need to go back to fundamentals and practice reading basic environmental indicators until the skill develops." "And how long should that take for someone with, say, absolutely no natural ability?" Santos pressed, generating another wave of snickers. The social isolation grew worse as word spread beyond their immediate training unit. During combined exercises with other military specialties, Loisa would overhear conversations between soldiers. She'd never met that somehow included references to that sniper who can't read wind. The story had apparently grown in the telling, with some versions claiming she'd missed an entire hillside during target practice, or that she'd needed a weather balloon to estimate a simple crosswind. The mess hall became particularly uncomfortable. Loisa started arriving early or late to avoid peak dining times, but even then she would catch fragments of conversations at nearby tables. She heard her name mentioned in connection with jokes about meteorologists, suggestions that the Army should issue her a personal windsock, and increasingly elaborate stories about her supposed training failures. "I heard she requested a transfer to the Weather Service," one soldier said during a conversation that was clearly intended for her to overhear. "Figured if she can't use wind information, maybe she could at least learn to predict it." "That's nothing," another replied. "My buddy in logistics says they're considering issuing her rubber bullets, so she can't accidentally hit something important when she misses." The jokes weren't limited to her peers. During a particularly challenging training exercise involving multiple wind conditions at different ranges, Master Sergeant Chun made what he probably thought was a motivational comment that instead became another source of humiliation. "Brock, at this point I'm starting to think you could miss a barn in a tornado," he announced in front of the entire class after she failed to compensate correctly for a shifting crosswind. "Maybe we should start you on stationary targets in a climate-controlled building." The comment was meant to push her toward improvement, but delivered in front of 20 other soldiers, it felt like an official confirmation of her incompetence. She could see some of her classmates exchanging looks that clearly said, "Even the instructors think she's hopeless." The psychological impact began affecting other aspects of her performance. During physical training, she found herself distracted and unfocused. Her normally excellent tactical exercises suffered as she second-guessed decisions that had nothing to do with marksmanship. Even her equipment maintenance, previously meticulous, became sloppy as her confidence eroded. Sleep became elusive. Loisa would lie awake replaying the day's failures, imagining the conversations happening in other barracks rooms, and dreading the next day's training. She started avoiding common areas during off-duty hours, spending time alone in the base library, or taking long walks around the perimeter fence where she was unlikely to encounter other soldiers. The worst incident occurred during a weekend barbecue organized by their training company. Loisa had initially planned to skip the event, but Sergeant Rodriguez had specifically encouraged her to attend, suggesting that social interaction outside of training might help rebuild relationships with her peers. It was a mistake. Someone had created a mock weather station using cardboard and markers, complete with spinning wind indicators and dramatic arrows showing shifting air currents. They'd labeled it Brock's Wind Reading Academy and positioned it prominently near the food tables where everyone would see it. When Loisa arrived and saw the display, accompanied by a handwritten sign reading, "Accuracy not guaranteed," she felt like she'd been physically punched. Brooks noticed her reaction and decided to escalate the situation. "Hey everyone," he announced, loudly raising his beer can like he was making a toast. "Let's have Brock give us a weather report. Think it's safe to grill outside, Sergeant? Or should we worry about mystery wind patterns that only you can see?" The crowd's attention focused on her like a spotlight. Some soldiers looked genuinely uncomfortable with the public humiliation, but others were clearly enjoying the spectacle. Loisa could feel her hands shaking as she stood there, surrounded by the people she was supposed to trust with her life in combat situations. "I think I'll pass," she managed to say, her voice steadier than she felt. "Ah, come on," Brooks continued, emboldened by the audience. "Just tell us which way the wind is blowing right now. Should be easy enough, right? It's not like you need to compensate for bullet drop or anything complicated." Loisa looked around the group, seeing expressions that ranged from cruel amusement to uncomfortable sympathy. She realized that everyone present would remember this moment, that it would become another story to tell about the sniper who couldn't handle basic environmental conditions. Instead of responding to Brooks, she turned and walked away from the barbecue, ignoring the calls behind her and the renewed laughter. As she headed back toward the barracks, she could hear Brooks providing commentary to the remaining crowd. Double quotes, "See what I mean? Can't even handle a simple question about wind direction. How's she supposed to handle combat conditions?" That night, alone in her room while her roommate attended the barbecue, Loisa seriously considered requesting a transfer to a different military specialty. The idea of spending months or years enduring this level of ridicule seemed unbearable. She drafted 3 different transfer requests, each one citing personal reasons or better utilization of skills in alternative roles. But each time she reached the signature line, something stopped her. Maybe it was pride or stubbornness, or simple refusal to give her tormentors the satisfaction of driving her away. Whatever the motivation, she couldn't bring herself to submit the paperwork. Instead, she pulled out her training notebook and began writing. Not technical notes about wind patterns or ballistic calculations, but a detailed analysis of every interaction, every joke, every moment of humiliation she'd experienced. She wanted to understand the psychology of what was happening to her, to identify the specific triggers and patterns that were making her situation worse. As she wrote, a pattern emerged that surprised her. The soldiers who mocked her most aggressively were often those who struggled with other aspects of sniper training. Brooks, for instance, had difficulty with range estimation under low light conditions. Santos sometimes rushed her shots under time pressure, sacrificing accuracy for speed. Jefferson had problems with equipment maintenance that had earned him several reprimands. They had found in her wind-reading difficulties a way to deflect attention from their own weaknesses. By making her the unit's designated failure, they could feel better about their own struggles and present themselves as competent by comparison. The realization didn't make the mockery less painful, but it gave her a different perspective on the situation. She wasn't just dealing with legitimate criticism of her performance. She was serving as a psychological safety valve for other people's insecurities. More importantly, she began to understand that her tormentors had inadvertently provided her with something valuable, a clear, specific goal that everyone would recognize as significant. If she could master wind reading to a level that exceeded their abilities, if she could demonstrate skills that made their mockery look foolish in retrospect, the psychological dynamic would shift dramatically. She just needed to figure out how to develop expertise that seemed to elude her despite months of conventional training. The standard methods weren't working, but maybe that meant she needed to find an unconventional approach. As she closed her notebook and prepared for bed, Loisa felt something she hadn't experienced in weeks. A sense of purpose that had nothing to do with meeting other people's expectations and everything to do with proving to herself that she could overcome what seemed impossible. She had no idea that her quest would eventually lead her to develop wind reading techniques so advanced that meteorologists would study her methods. or that the soldiers currently mocking her would someday ask for her advice on environmental assessment. All she knew was that she refused to let their ridicule define the limits of her abilities. The mockery had reached its peak, but so had her determination to transcend it. The incident that changed everything happened on a Tuesday morning that started like any other. Loisa had arrived at the range early, hoping to get some practice time before the rest of her unit showed up for the day's training exercises. The weather conditions were particularly challenging, gusty winds that seemed to shift direction every few minutes, creating the kind of unpredictable environment that had become her personal nightmare. She was setting up her equipment when she noticed an older man in civilian clothes standing near the observation tower, watching the few soldiers who were already practicing. Something about his posture and the way he studied the range suggested military experience, but his weathered face and gray beard indicated he was long past active duty. He carried a notebook and seemed to be making detailed observations about wind patterns and their effects on the shooter's performance. Curiosity got the better of her anxiety. During a break between practice rounds, Loisa approached the observation area where the stranger was seated. "Excuse me, sir," she said politely. "Are you here for the training evaluation?" The man looked up from his notebook with sharp blue eyes that seemed to take in everything about her, her posture, her equipment setup, even the slight tremor in her hands that she thought she'd been hiding successfully. "Not exactly," he replied, with a slight smile. "I'm Dr. James Patterson. I used to teach atmospheric physics at Colorado State before I retired. Now I consult with various military units on environmental factors affecting long-range precision." He gestured toward the range. "Your commanding officer asked me to observe today's training and provide some recommendations for curriculum improvements." Loisa felt her stomach drop. Great, another expert who would witness her struggles and probably recommend her removal from the program. "I see," she managed to say. "You're having trouble with wind reading," Patterson said matter-of-factly. It wasn't a question. Heat flooded Loisa's face. "Is it that obvious?" "To someone who knows what to look for, yes." Patterson closed his notebook and studied her more carefully. "But not for the reasons you might think. May I ask you something? When you're trying to read wind conditions, what's going through your mind?" The question caught her off guard. Most instructors focused on technique and results, not mental processes. I try to remember everything I've been taught. Watch the grass, check the mirage, feel the wind on my face. But it all seems contradictory. The indicators don't match up, and I can't figure out which ones to trust. Patterson nodded slowly. "That's because you're trying to apply cookbook solutions to a complex dynamic system. Tell me, what's your educational background before the military?" "I studied environmental engineering at the University of Nebraska for 2 years before enlisting," Loisa replied, wondering where this was leading. "Engineering," Patterson repeated with interest. "So you understand systems analysis, mathematical modeling, pattern recognition?" "Yes, sir. I was actually pretty good at those subjects." "But no one's taught you to apply engineering principles to wind reading, have they? They've given you rules of thumb and general guidelines, but not the underlying physics that would let you build your own understanding." Loisa stared at him. In all her months of training, no instructor had ever suggested that her analytical background might be an asset rather than irrelevant to marksmanship. "No, sir. We mostly focus on practical field techniques." Patterson reopened his notebook and showed her a page covered with diagrams, equations, and detailed observations. "This is how I analyze wind patterns. Not just watching grass bend or feeling air movement, but understanding the fluid dynamics of air masses, the effects of terrain on airflow, the thermal patterns that create updrafts and downdrafts." The page looked like something from her old engineering textbooks, complex but logical, systematic rather than intuitive. For the first time in months, Loisa felt like she was looking at something that made sense. Most snipers learn wind reading through experience and instinct, Patterson continued. They develop a feel for it over time. But some people, especially those with technical backgrounds, need to understand the science before they can develop the intuition. You might be one of those people. You think that's why I've been struggling? I think you've been trying to force yourself to think like a traditional sniper when your brain is wired like an engineer. Instead of fighting that, what if we worked? With it, the conversation was interrupted by the arrival of Master Sergeant Chun and the rest of the training unit. Patterson excused himself to conduct his official observations, but not before handing Loisa a business card. If you're interested in a different approach to wind reading, give me a call tonight, he said quietly. I have some ideas that might help. The rest of the training day proceeded as usual, which meant poorly for Loisa. She missed several shots that should have been manageable, drew the usual comments from her peers, and felt the familiar frustration building. But for the first time in weeks, she also felt something else, hope that there might be a solution she hadn't considered. That evening, Loisa called the number on Patterson's card from a payphone outside the base exchange, not wanting to have this conversation where others might overhear. Dr. Patterson? This is Sergeant Brock. You said I could call about wind reading techniques. Loisa, I was hoping you would. I've been thinking about our conversation, and I believe I can help you. But it's going to require a completely different approach than what you've been taught. Are you willing to essentially start over with wind reading? At this point, I'm willing to try anything. Good. Can you meet me Saturday morning at the civilian range outside Colorado Springs? I'd like to work with you away from your regular training environment, where you can focus on learning without worrying about peer reactions. The civilian range was a 30-minute drive from Fort Carson, nestled in a valley that created interesting wind patterns due to the surrounding hills and varying elevations. When Loisa arrived that Saturday, she found Patterson setting up an array of equipment she'd never seen before. Digital anemometers, wind direction indicators, even a small weather station connected to a laptop computer. Before we touch a rifle, Patterson said by way of greeting, we're going to turn you into a meteorologist. You can't read wind effectively until you understand what wind actually is and how it behaves. For the next 3 hours, Patterson walked her through the physics of air movement. He explained how temperature differentials create pressure gradients, how terrain features channel and redirect airflow, how atmospheric layers interact to create complex wind patterns. He showed her how to use the digital instruments to measure conditions at different elevations and distances, then correlate those measurements with the environmental indicators she'd been taught to observe. See this? Patterson pointed to his laptop screen, which displayed a real-time wind map of the range area. The grass near the 300-yard line is showing a left-to-right wind, but the computer data shows the wind at bullet height is actually moving right to left. Most shooters would be fooled by the surface indicators. Loisa studied the display, comparing the electronic readings to what she could observe with her eyes. So the grass is showing the surface wind, but the bullet is traveling through a different air mass? Exactly. This happens more often than most snipers realize, especially in terrain like this. Traditional wind reading techniques assume uniform conditions, but real-world ballistics deal with layered, complex airflow patterns. They spent the morning learning to read the electronic instruments, but Patterson's real goal was teaching Loisa to understand the principles behind the measurements. He wanted her to develop the ability to predict wind behavior based on scientific understanding, not just observe current conditions. Now comes the interesting part, Patterson said after lunch. We're going to teach you to calculate wind effects, using actual physics equations, not just the simplified formulas they give snipers. He pulled out a tablet loaded with ballistic software that looked more sophisticated than anything Loisa had seen in military training. The program allowed users to input detailed environmental data, not just wind speed and direction, but temperature gradients, humidity levels, barometric pressure, even terrain elevation changes that might affect bullet flight. This is how aerospace engineers calculate missile trajectories, Patterson explained. Same principles apply to rifle bullets, just at a smaller scale. Instead of guessing at wind effects, you're going to learn to calculate them precisely. For the first time since beginning sniper training, Loisa felt like she was in her element. The software interface reminded her of the engineering programs she'd used in college, and the mathematical approach to problem solving felt natural and comfortable. Within an hour, she was inputting complex environmental data and generating predicted bullet paths that accounted for multiple variables. The key insight, Patterson continued as she worked through the calculations, is that wind reading isn't really about reading wind at all. It's about predicting the three-dimensional path your bullet will take through a dynamic fluid environment. Once you understand that, everything else becomes engineering. When they finally moved to actual shooting, the results were dramatic. Using the calculated corrections based on the detailed environmental analysis, Loisa's first shot struck within 2 inches of the target center at 600 yards. Her second shot was even closer. "How does that feel?" Patterson asked as she lowered her rifle, staring at the target in disbelief. "Like everything finally makes sense," Loisa replied honestly. "All those months of trying to develop intuition when what I really needed was better data and proper calculations." They spent the rest of the afternoon refining the technique, with Patterson teaching her shortcuts and field expedient methods for gathering the necessary environmental data without electronic instruments. He showed her how to estimate temperature gradients by observing terrain features, how to detect wind layers by watching different types of vegetation, how to use her engineering background to build mental models of complex airflow patterns. "This is just the beginning," Patterson warned as they packed up the equipment. "Mastering this approach will take months of practice, and you'll need to develop speed and accuracy under pressure. But you've demonstrated today that you have the fundamental ability. The question is whether you're committed to putting in the work." Loisa looked back at the target, still amazed by the afternoon's results. After months of failure and humiliation, she had finally found an approach that worked with her natural abilities rather than against them. "I'm committed," she said, "whatever it takes." As she drove back to Fort Carson that evening, Loisa felt a transformation beginning that went beyond just improved marksmanship. For the first time since enlisting, she felt like she had found a way to be authentically herself while excelling in her military role. She didn't need to become a different person to succeed. She needed to apply her existing strengths in a smarter way. She had no idea that her newfound understanding would eventually lead her to attempt a shot that would challenge everything the military thought it knew about wind reading capabilities. But she was beginning to suspect that her struggles were about to become someone else's problem. The transformation didn't happen overnight. Over the following weeks, Loisa began living a double life, struggling through official training during the day while secretly developing her scientific approach to wind reading during every spare moment. The challenge was practicing her new techniques without drawing attention from her peers, who were still enjoying their role as her critics. Dr. Patterson had given her access to a specialized ballistics app on her personal phone, along with a compact digital anemometer that looked like a standard multi-tool to casual observers. During breaks in training, while other soldiers socialized or rested, Loisa would discreetly gather environmental data and run calculations. She learned to estimate atmospheric pressure using weather apps, to judge temperature gradients by observing how heat waves behaved at different elevations, and to detect wind layers by studying the movement of clouds, dust particles, and even insects. The most challenging aspect was learning to make these calculations quickly enough to be practical in real shooting situations. Patterson's initial method required several minutes of data collection and mathematical analysis too slow for military applications, where rapid target engagement might be necessary. Loisa needed to develop shortcuts and approximation techniques that would give her accurate results in 30 seconds or less. She started carrying a small, waterproof notebook where she recorded abbreviated formulas and reference tables. During lunch breaks, she would find isolated spots around the base where she could practice her rapid environmental assessment techniques. The old equipment maintenance shed behind the motor pool became her unofficial laboratory, where she could set up her instruments and practice calculations without curious observers. Asterisk. The breakthrough came during a particularly difficult training exercise in the third week of her secret practice sessions. The official scenario involved engaging targets at multiple ranges under shifting wind conditions, exactly the type of challenge that had been her weakness. But this time, instead of relying on traditional wind reading methods, Loisa discreetly gathered her environmental data and ran her calculations. Her first shot at 400 yards was a perfect center hit. The second, at 650 yards with a different wind angle, struck within an inch of the bullseye. By her third shot, she noticed that conversations around the firing line had quieted as other soldiers began paying attention to her. Sudden improvement. "Not bad, Brock," Master Sergeant Chen commented after reviewing her target results. "Whatever you've been working on, keep it up." The comment was meant as encouragement, but Loisa could see the suspicious looks from some of her peers. Tyler Brooks, in particular, seemed annoyed that his favorite target for ridicule was showing unexpected competence. Lucky day for wind conditions. Brooks muttered to the soldiers around him, "Let's see how she does when it really starts blowing." The challenge came sooner than expected. The following Friday brought a storm system that created some of the most difficult shooting conditions Loisa had ever encountered. Winds were gusting up to 40 miles per hour with frequent direction changes, and visibility was reduced by intermittent rain squalls. Most of the training exercises were postponed, but Master Sergeant Chun decided to conduct a voluntary advanced training session for soldiers who wanted to test their skills against extreme conditions. Loisa volunteered immediately, knowing this would be the ultimate test of her new approach. Only 6 soldiers from their unit chose to participate, including Brooks, who had volunteered specifically to watch her fail. Under challenging conditions, the exercise targets were placed at 800 yards, a significant distance under normal conditions. Nearly impossible under the current weather. Each shooter would have 1 magazine of 5 rounds to engage the target, with scoring based on accuracy and consistency. Brooks went first, struggling visibly with the shifting winds. His shots scattered across the target area with only 2 hitting the scoring zones. 2 other soldiers fared similarly, managing partial success but clearly fighting the environmental conditions. When Loisa's turn came, she took extra time with her environmental assessment, discreetly using her phone app to gather detailed atmospheric data while appearing to simply study the range conditions. The other soldiers interpreted her careful preparation as nervousness, but she was actually building a comprehensive 3-dimensional model of the current wind patterns. Her calculations indicated something that conventional wind reading would miss. While the surface winds were gusting chaotically from multiple directions, the air mass at bullet height was following a more predictable pattern, flowing generally from southwest to northeast with periodic circular eddies caused by the terrain features. She loaded her rifle and took her shooting position. The first shot required a significant adjustment to compensate for what her calculations predicted, a correction that would seem wrong to anyone using traditional wind reading methods. She squeezed the trigger and watched through her scope as the bullet struck the center ring of the target. A murmur went through the small group of observers. In conditions this challenging, even experienced shooters considered any hit on the target a success. Her second shot was even more impressive, striking within inches of her first hit despite a noticeable change in surface wind direction. By her third shot, she could see Brooks staring at her with undisguised confusion and growing resentment. When she completed her 5-shot string, with all rounds in the target center area, something none of the other shooters had achieved, the silence from her peers was profound. Master Sergeant Chen walked out to retrieve the target personally, studying the tight shot group with obvious amazement. "Outstanding shooting, Sergeant Brock," he announced loudly enough for everyone to hear. "This is some of the finest wind reading I've seen from any soldier in this unit." The praise felt good, but Loisa could see that her sudden competence had created a new problem. Brooks and several other soldiers were looking at her with suspicion rather than admiration. Her improvement was too dramatic, too sudden to seem natural. "How did you do that?" Brooks asked as they cleared their weapons and prepared to leave. "The range," his tone wasn't congratulatory, it was accusatory. "6 weeks ago you couldn't hit a target in a light breeze, and now you're shooting perfect groups in a near hurricane." "I've been practicing," Loisa replied carefully, not wanting to reveal her methods. "Practicing what?" "Because whatever you did out there, it wasn't standard wind reading techniques." The conversation was drawing attention from the other soldiers, and Loisa realized she was walking into a potentially dangerous situation. If her peers suspected she was using unauthorized methods or equipment, it could lead to formal investigations that might end her military career. "I've been studying atmospheric conditions more carefully," she said, which was technically true. "Trying to understand the science behind wind patterns instead of just relying on rules of thumb." Brooks didn't look satisfied with the explanation. But before he could press further, Master Sergeant Chun intervened. "Whatever Sergeant Brock has been doing, it's working," Chun said firmly. "I suggest the rest of you focus on improving your own performance instead of questioning hers." That evening, Loisa called Dr. Patterson from the payphone to report her success and seek advice about the growing suspicion from her peers. "You're facing a classic problem," Patterson told her. "When someone suddenly demonstrates abilities that seem beyond their previous performance level, people naturally assume they're either cheating or hiding some advantage. The key is to gradually reveal your methods in a way that seems like natural progression rather than sudden transformation." "How do I do that without compromising the techniques you've taught me?" "Start teaching simplified versions to the soldiers who seem most receptive. Not the full scientific approach, but basic principles that will improve their performance. If you can help others succeed using your methods, the suspicion will turn into respect." Patterson's advice proved prescient. Over the following week, Loisa began sharing basic atmospheric physics concepts with soldiers who approached her for advice. She taught them to recognize temperature inversions that could affect bullet flight, to identify terrain features that created predictable wind patterns, and to use smartphone weather apps for more accurate environmental data. Jessica Martinez, her roommate, was the first to benefit from these insights. During a training exercise, Loisa quietly pointed out thermal columns rising from sun-heated rocks that were creating updrafts across the bullet path. Martinez adjusted her aim accordingly and achieved her best shooting score to date. "That was incredible," Martinez said afterward. "Where did you learn about thermal effects on bullet flight?" "I've been reading meteorology texts in the base library," Loisa replied, which was another technical truth. Turns out there's a lot of science behind environmental shooting conditions that they don't cover in basic training. Word began spreading that Loisa had developed some kind of advanced understanding of atmospheric conditions. Instead of mockery, soldiers started approaching her with genuine questions about wind reading techniques. Even some of the instructors began consulting with her about environmental factors during training exercises. But her most important validation came from an unexpected source. During a multi-unit training exercise, Colonel Sarah Mitchell, the base commander, was observing advanced marksmanship training when she noticed Loisa's consistent performance under varying conditions. "Sergeant Brock," Colonel Mitchell said after watching her complete another successful wind reading demonstration, "I understand you've developed some innovative approaches to environmental shooting challenges. Would you be interested in presenting your techniques to our instructor development program?" The invitation was both an opportunity and a risk. Formal presentation of her methods would provide official recognition and validation, but it would also expose her techniques to detailed scrutiny from experienced instructors who might identify aspects that violated standard protocols. "I'd be honored, ma'am," Loisa replied, knowing she had passed the point where she could continue operating in secret DAT as she prepared for what would become her first official teaching presentation. Loisa realized that her journey had reached another critical juncture. She had proven to herself and others that her scientific approach to wind reading was effective, but now she would need to convince military leadership that her methods deserved to be incorporated into standard training curricula. What she didn't yet know was that her presentation would lead to an opportunity that would test her abilities far beyond anything she had previously imagined and provide the perfect stage for demonstrating that her mastery of wind reading had reached levels that traditional snipers considered impossible. The instructor development presentation was scheduled for a Wednesday morning in the base's main conference room with an audience that included senior NCOs, training specialists, and visiting personnel from other installations. Loisa had spent the previous weekend preparing a carefully balanced presentation that would showcase her techniques without revealing the full extent of her scientific methodology. She needed to appear innovative but not revolutionary, advanced but not threatening to established training protocols. Dr. Patterson had helped her prepare presentation materials that emphasized practical applications rather than theoretical foundations. Instead of complex atmospheric physics equations, she focused on simplified field techniques that any soldier could learn. Her slides showed before and after target results, basic environmental assessment tools, and step-by-step procedures for improving wind reading accuracy. The presentation went better than expected. The audience was attentive and asked thoughtful questions about implementation. Several instructors expressed interest in incorporating her techniques into existing curricula. Colonel Mitchell seemed particularly impressed by the documented performance improvements among soldiers who had learned Loisa's methods. "Sergeant Brock," the colonel said during the question period, "you've clearly developed something valuable here. How confident are you in these techniques under extreme conditions?" It was a loaded question. Loisa could sense that her answer would determine whether her methods were accepted as useful supplements to standard training or dismissed as interesting but impractical innovations. "Very confident, ma'am," she replied. "The scientific principles behind environmental assessment remain consistent regardless of conditions. More extreme environments simply require more precise calculations and measurements." "Interesting," Colonel Mitchell mused, "because we have an upcoming situation where extreme precision under challenging conditions will be essential." The room grew quiet. Several of the senior personnel exchanged meaningful looks that suggested they were aware of something Loisa wasn't being told. Master Sergeant Robert Hayes, the base's senior marksmanship instructor, leaned forward in his chair. "Colonel, are you thinking about the Blackwater Canyon demonstration?" "I am indeed," Mitchell replied. "Sergeant Brock, are you familiar with the Joint Service Precision Shooting Competition that's held annually at various military installations?" "Yes, ma'am. I know it's considered one of the most challenging marksmanship events in the military. This year, Fort Carson has been selected to host the competition, and we're expected to showcase innovative training techniques and demonstrate capabilities that reflect well on our installation. One of the planned events is what they call the Impossible Shot Challenge, a precision shooting demonstration under conditions so difficult that success is considered nearly impossible." Loisa felt her pulse quicken. She had heard rumors about the Impossible Shot Challenge, legendary demonstrations where elite snipers attempted shots that pushed the boundaries of human capability and equipment limitations. Colonel Mitchell continued, "This year's challenge will take place at Blackwater Canyon, about 40 miles northwest of here. It's a location specifically chosen because the terrain creates some of the most complex and unpredictable wind patterns in Colorado. The shot distance will be 1,200 yards, and historical wind data indicates crosswind speeds of up to 60 miles per hour with frequent direction changes. The numbers were staggering. Most military snipers considered 1,000 yards a long shot under ideal conditions. Adding extreme crosswinds and extending the distance to 1,200 yards would create a challenge that bordered on impossible. Teams from every major military installation will be attending, Mitchell added. Special Forces, Marine Scout snipers, Army Rangers, even some Navy SEALs. The competition has received significant media attention, and there will be civilian shooting experts observing as well. Master Sergeant Hayes spoke up again. Ma'am, with respect, the Blackwater Canyon shot has never been completed successfully. 3 years ago, a Marine sniper came close, but even he missed by several feet. The wind patterns there are just too chaotic for conventional wind reading techniques, which is exactly why I'm considering Sergeant Brock for the demonstration. Colonel Mitchell replied. Her methods appear to be anything but conventional. The room fell silent as the implications became clear. Colonel Mitchell was suggesting that Loisa, who 6 months earlier had been the unit's worst performer in wind reading, should represent Fort Carson in the most challenging precision shooting demonstration in the military. Ma'am, Loisa said. Carefully, I'm honored by your confidence, but this would be a significant responsibility. If I failed publicly, it would reflect poorly on Fort Carson and on the training methods we've been developing. That's true, Mitchell acknowledged. But if you succeeded, it would demonstrate that our installation is developing the most advanced marksmanship training in the military. It would also validate your techniques in a way that no amount of classroom presentation could achieve. Tyler Brooks, who had been invited to the presentation as one of the unit's top conventional shooters, couldn't contain himself any longer. Colonel Mitchell, with all due respect, this seems like an enormous risk, Brooks interjected. Sergeant Brock has only recently started showing improvement in her wind reading skills. To put her in a situation where failure would be so public... Shouldn't we consider a more experienced sniper? The question hung in the air like a challenge. Loisa could see that several people in the room shared Brooks' concern, even if they were too diplomatic to voice it directly. That's a fair point, Specialist Brooks, Colonel Mitchell replied, which is why I'm not making this decision unilaterally. Sergeant Brock, I want you to demonstrate your capabilities under conditions that approximate what you would face at Blackwater Canyon. If you can prove that your techniques work under extreme conditions, you'll have my full support for the competition. What kind of demonstration are you proposing, ma'am? Next week, we're going to set up a test shot at our most challenging range location, the Ridgeline facility that approximates Blackwater Canyon's wind patterns. You'll attempt a 1,000-yard shot under whatever conditions nature provides. If you can hit the target consistently, I'll submit your name for the competition. Master Sergeant Hayes looked skeptical. Colonel, the Ridgeline Range has some of the most unpredictable wind conditions on the base. Even our most experienced instructors struggle with shots over 800 yards there, which makes it perfect for testing Sergeant Brock's claims about advanced wind reading techniques, Mitchell replied. If her methods can handle the Ridgeline Range, they might actually work at Blackwater Canyon. Loisa felt the weight of expectation settling on her shoulders. She had gone from struggling with basic wind reading to being offered the opportunity to represent her installation in the military's most prestigious marksmanship challenge. The progression felt almost surreal. I accept the challenge, ma'am, she said, knowing that backing down would be professional suicide. When would you like to conduct the demonstration? How about Friday morning? That gives you the rest of this week to prepare. I'll invite key personnel from the base to observe, and we'll document everything for potential inclusion in future training materials. As the meeting broke up, Loisa found herself surrounded by people offering advice, expressing concern, or simply wanting to be associated with what was becoming a major event on the base. But it was Brooks who pulled her aside as they left the conference room. "You know you're in over your head, right?" he said quietly, his tone more concerned than hostile. "This isn't about proving a point anymore. You're about to represent Fort Carson in front of people who could end your career if you fail badly enough." "I understand the stakes," Loisa replied. "Do you? Because if you miss that shot on Friday, Colonel Mitchell's going to look foolish for supporting you, and you're going to be transferred to some administrative position where your shooting skills won't matter. And if you somehow make it to Blackwater Canyon and fail there... double quotes, Brooks shook his head. "That would be a career-ending humiliation that follows you for the rest of your military service." For a moment, Loisa saw genuine concern in Brooks' expression, rather than the antagonism she'd grown accustomed to. He wasn't trying to discourage her out of malice. He was genuinely worried that she was about to destroy herself professionally. "Thank you for the warning," she said sincerely. "But I think you might be surprised by what I can do now." That evening, Loisa called Dr. Patterson to inform him about the challenge and seek his advice about preparation strategies. 1,200 yards and 60-mile-per-hour crosswinds, Patterson repeated thoughtfully. "That's not just a shooting challenge, it's an engineering problem. The ballistic calculations become exponentially more complex at that distance with those wind conditions. Do you think it's actually possible? With conventional wind reading techniques, probably not. But with the scientific approach we've been developing, double quotes, Patterson paused, considering. We'd need to create a much more sophisticated environmental model than anything you've used before. 3-dimensional wind mapping, precise atmospheric density calculations, probably real-time ballistic modeling. Is that something we can develop in a week? For the test shot on Friday, we can give you the tools you'll need. For Blackwater Canyon, if you make it that far, we'd need to develop something entirely new. Something that would revolutionize how precision shooting is approached." As Loisa hung up the phone, she realized that she had committed herself to something that would either validate everything she'd worked toward or destroy her military career in the most public way possible. But for the first time since accepting the challenge, she felt a familiar sensation, the same analytical excitement she'd experienced in college when tackling impossible engineering problems. She wasn't just preparing for a shooting demonstration anymore. She was about to attempt something that would redefine what was considered possible in precision marksmanship. The question was whether her scientific approach to wind reading was advanced enough to achieve what conventional snipers considered impossible. The week between accepting the challenge and the Friday demonstration passed in a blur of intense preparation that pushed both Loisa and Dr. Patterson to the limits of their expertise. They had essentially committed to developing a wind reading system more advanced than anything previously attempted in military marksmanship, and they had less than 5 days to make it work. Patterson arrived at Fort Carson on Wednesday morning with equipment that looked more suited to a meteorological research station than a shooting range. In addition to his standard atmospheric monitoring devices, he brought a portable Doppler radar unit, a laser range finder capable of measuring atmospheric density at multiple distances, and a ruggedized laptop loaded with computational fluid dynamics software normally used by aerospace engineers. "What we're attempting," Patterson explained as they set up the equipment at the Ridgeline Range, "is to create a real-time, 3-dimensional model of air movement throughout the entire bullet flight path. Instead of estimating wind conditions, we're going to map them with scientific precision." The Ridgeline Range was a natural amphitheater carved into the Colorado foothills, with the shooting position elevated about 200 feet above the target area. The terrain features that made it challenging for conventional wind reading, rocky outcroppings, thermal differences between sun and shade, elevation changes that created unpredictable air currents, would provide perfect test conditions for their advanced system, Loisa spent Wednesday afternoon learning to operate the new equipment, while Patterson fine-tuned the software to process environmental data in real time. The Doppler radar could detect air movement at multiple elevations and distances, creating a detailed picture of wind patterns throughout the bullet's flight path. The density measurements would allow them to calculate precise atmospheric effects on bullet velocity and trajectory. The key insight, Patterson said as they worked through the calibration process, is that we're not just reading current wind conditions. We're predicting what those conditions will be during the 1.2 seconds it takes your bullet to reach the target. The computational challenge was staggering. A bullet traveling 1,000 yards through complex terrain would encounter dozens of different air masses, each with unique characteristics that would affect its flight path. Traditional wind reading assumed relatively uniform conditions, but their system would account for every variation along the trajectory. Thursday morning brought their first full system test. The weather conditions were moderately challenging. 20-mile-per-hour winds, with periodic gusts and direction changes that would stress conventional shooting techniques. Patterson set up his monitoring equipment, while Loisa prepared her rifle and began gathering baseline environmental data. "Remember," Patterson said as she took her shooting position, "you're not just a sniper anymore. You're a ballistics engineer, using precision instruments to solve a complex physics problem." The first shot required 10 minutes of data collection and calculation. The software processed atmospheric readings from multiple points along the bullet path, calculated thermal effects on air density, and generated trajectory predictions that accounted for wind variations at different elevations. When Loisa finally squeezed the trigger, the bullet struck within 3 inches of the target center, remarkable accuracy for the challenging conditions. "That was impressive," Patterson said, studying the computer readouts. "But 10 minutes is too long for practical application. We need to streamline the process." They spent Thursday afternoon developing shortcuts and approximation techniques. Patterson programmed the software to make certain assumptions about atmospheric conditions, reducing calculation time while maintaining accuracy. Loisa practiced rapid data collection techniques, learning to gather essential measurements in under 2 minutes. By Thursday evening, they had reduced their shot preparation time to 3 minutes while maintaining SOV-MOA, minute of angle, accuracy, precision. That would place every shot within a 1-inch circle at 100 yards, scaled proportionally for longer distances. For 1,000-yard shots, this meant consistent accuracy within 10 inches of the point of aim. But they both knew that Friday's demonstration would present challenges beyond their practice sessions. Colonel Mitchell had made it clear that the test would take place under whatever conditions nature provided, and weather forecasts indicated the possibility of severe windstorms moving through the area. Friday morning dawned gray and windy, with gusts already reaching 35 miles per hour by 0700 hours. As Loisa and Patterson arrived at the ridgeline range, they could see that the observation area was crowded with personnel who had come to witness what was being called the most significant marksmanship demonstration in Fort Carson's recent history. Colonel Mitchell was present, along with visiting officers from other installations, senior NCOs from various specialties, and a delegation of civilian shooting experts who had been invited to observe. Loisa counted at least 40 people in the audience, including several she recognized as critics who probably hoped to see her fail. Tyler Brooks was there, of course, along with most of her training unit. But she was surprised to see supportive faces as well. Jessica Martinez, several soldiers she had helped with wind reading techniques, and even Master Sergeant Chen, who offered her an encouraging nod. "Ladies and gentlemen," Colonel Mitchell announced to the assembled crowd, "today, we're going to witness a demonstration of advanced environmental shooting techniques developed here at Fort Carson. Sergeant Brock will attempt a precision shot at 1,000 yards under current wind conditions. A murmur went through the crowd as people studied the weather conditions. Even those unfamiliar with precision shooting could see that the wind was severe. With dust and debris swirling visibly across the range, Master Sergeant Hayes, serving as range safety officer, provided technical commentary for the observers. Current wind conditions are gusting to 45 miles per hour with frequent direction changes. These are conditions that would challenge the most experienced snipers in the military. Patterson began setting up the monitoring equipment while Loisa prepared her rifle and conducted her initial environmental assessment. She could feel the weight of 40 pairs of eyes watching her every movement, analyzing her techniques, waiting to see if her confident claims would translate into actual performance. The first data collection took longer than their practice sessions, because the wind patterns were more complex than anything they had encountered during preparation. The Doppler radar showed air masses moving in different directions at various elevations, with thermal currents creating vertical wind components that would affect bullet flight. "This is fascinating," Patterson said quietly as he studied the computer readouts. "The air movement here is creating a three-dimensional spiral pattern. Conventional wind reading would miss this completely." 20 minutes into the demonstration, Loisa was still gathering data and running calculations. She could sense restlessness in the crowd, hear whispered comments about delays and overthinking. Some observers were probably questioning whether her methods were practical for real-world applications. "Take your time, Sergeant," Colonel Mitchell called out. "Accuracy is more important than speed for this demonstration." Finally, after 25 minutes of preparation, Loisa took her shooting position. The calculations indicated wind conditions that seemed almost impossible, a crosswind component of 38 miles per hour from the right, but with vertical air movement that would cause the bullet to rise during the first third of its flight path and drop more rapidly during the final approach to the target. She loaded a single round, adjusted her scope according to the calculated corrections, and controlled her breathing. The crowd fell silent as she prepared to fire. Even the constant wind seemed to quiet for a moment. The shot echoed across the range like thunder. Through her scope, Loisa watched the bullet's trace as it followed what appeared to be an impossible curved path through the air, rising initially before dropping toward the target. When the bullet struck, it hit within 6 inches of the center ring. Remarkable accuracy under the severe conditions. The crowd erupted in applause and amazed conversation. Several officers approached Patterson to examine his equipment and ask technical questions about the calculation methods. Colonel Mitchell wore an expression of satisfaction that suggested she had witnessed exactly what she had hoped to see. But Loisa barely heard the congratulations. She was already thinking about Blackwater Canyon, where the wind conditions would be twice as severe and the distance 200 yards longer. What they had accomplished today was impressive, but it was only a preview of the challenge that awaited her. "Outstanding work, Sergeant Brock," Colonel Mitchell said as the crowd began to disperse. "You've earned your spot in the competition. We'll submit your name for the Blackwater Canyon demonstration next month." As Loisa packed up her equipment, she realized that her journey had reached another inflection point. She had proven that her scientific approach could handle extreme conditions, but she had also committed herself to an even greater challenge. The impossible shot at Blackwater Canyon would test not just her technical abilities, but whether she could perform under the most intense pressure imaginable. For the first time since beginning this journey, she felt ready for whatever came next. She had the tools, the knowledge, and most importantly, the confidence that came from understanding the science behind what others considered impossible. The month between her successful demonstration and the Blackwater Canyon competition passed with an intensity that transformed Loisa from a competent sniper into something approaching a ballistic scientist. Dr. Patterson had secured approval to conduct advanced research at the actual competition site, and they spent 3 weeks mapping the canyon's unique atmospheric Characteristics in preparation for what everyone acknowledged would be the most challenging precision shot ever attempted. Blackwater Canyon was a geological marvel that created atmospheric conditions unlike anywhere else in North America. The canyon ran east-west for nearly 2 miles, with steep granite walls that rose 800 feet on either side. This natural wind tunnel concentrated and accelerated air movement, creating sustained winds that regularly exceeded 50 miles per hour. But the real challenge came from the thermal effects. Sun-heated rock faces created powerful updrafts that collided with cool air descending from the canyon rim, generating turbulence patterns that changed constantly throughout the day. This isn't just wind reading, Patterson explained as they studied months of historical weather data from the site. This is like trying to predict the behavior of a chaotic fluid system. The air movement here defies conventional meteorological models. The competition setup was deliberately designed to maximize difficulty. The shooting position was located on the north rim of the canyon, 1,200 yards from a target placed on a narrow ledge on the south wall. The bullet would have to travel not just across the canyon's width, but also down through multiple layers of turbulent air, each with different characteristics. Previous attempts at the Blackwater Canyon shot had become legendary failures. A Marine Corps sniper had missed by 8 feet despite perfect shooting fundamentals. A Navy SEAL had watched his bullet curve so dramatically that it struck the canyon wall 30 yards from the target. An Army Ranger had given up after spending 40 minutes trying to read wind conditions that seemed to change every few seconds. The psychological pressure is almost as challenging as the technical difficulty, warned Lieutenant Colonel Sandra Hayes, who served as the competition coordinator. You'll be shooting in front of representatives from every major military unit, plus civilian experts and media observers. If you miss, everyone will know within minutes. The week before the competition, Loisa and Patterson conducted their final preparation at a specially constructed training facility that approximated Blackwater Canyon's conditions. Using powerful fans and heat sources, they created artificial wind patterns that allowed Loisa to practice her rapid environmental assessment techniques under controlled conditions. The breakthrough came during their last practice session, when Patterson introduced a revolutionary modification to their calculation system. Instead of trying to predict exact wind conditions throughout the bullet's flight path, they would calculate probability ranges for different scenarios and select the optimal aim point based on statistical analysis. Think of it as quantum ballistics, Patterson explained, showing her the new software interface. Instead of assuming we can predict exactly what the wind will do, we calculate the most likely outcomes and aim for the solution that maximizes our probability of success. The system was elegant in its complexity. The software would gather environmental data, generate thousands of possible wind scenarios based on the canyon's historical patterns, calculate ballistic solutions for each scenario, and identify the aim point that would result in a target hit under the greatest number of conditions. Competition day dawned clear and windy, with sustained winds already reaching 45 miles per hour by sunrise. As Loisa arrived at Blackwater Canyon, she was struck by the dramatic beauty of the location and the obvious technical challenge it presented. The canyon was a natural amphitheater that seemed designed to humble human precision. The audience was larger than she had expected. Military observers occupied bleacher seating on both rims of the canyon, with media personnel positioned at strategic locations to capture the event. She recognized faces from various elite units, including several snipers whose reputations were legendary within the military community. "Ladies and gentlemen," announced General Patricia Rodriguez, the competition director, "today we witness an attempt at what has been called the most difficult precision shot in military history. Sergeant Loisa Brock from Fort Carson will attempt to engage a target at 1,200 yards under extreme wind conditions that have defeated every previous challenger." A demonstration of current wind conditions left no doubt about the difficulty. A brightly colored streamer released from the shooting position was immediately caught in violent air currents, spinning and tumbling in patterns that seemed to defy physics before disappearing into the canyon's depths. Tyler Brooks, who had been selected to provide technical commentary for the military observers, couldn't hide his skepticism. "Ladies and gentlemen, what you're seeing is wind behavior that makes conventional marksmanship techniques essentially useless. Even the most experienced snipers consider these conditions impossible for precision shooting." Loisa began her environmental assessment while Patterson set up the monitoring equipment. The initial data readings were more extreme than anything they had encountered during practice. Wind speeds were gusting to 65 miles per hour with direction changes occurring every few seconds. Temperature differentials between the canyon walls created thermal columns that rose like invisible tornadoes throughout the shooting corridor. "This is beyond anything we modeled," Patterson said quietly as he studied the computer readouts. "The turbulence patterns are more complex than our simulations predicted." For 30 minutes, they gathered data and refined their calculations. The crowd grew restless as the preparation time extended, with some observers questioning whether the conditions were simply too severe for any shot attempt. Several betting pools had formed among the military personnel, with odds heavily favoring a spectacular miss. Finally, the software generated its recommendation, a aim point that seemed to defy logic, requiring corrections that would appear completely wrong to anyone using conventional wind reading methods. The ballistic solution called for aiming nearly 20 feet to the left of the target and 2 feet high, compensating for wind effects that would push the bullet in a complex curved path through the canyon's turbulent air. "Trust the math," Patterson said as Loisa prepared to take her shooting position. "Everything we've learned, everything we've calculated, says this solution gives us the best chance of success." Loisa loaded a single match-grade round into her rifle and adjusted her scope according to the calculated corrections. The crowd fell silent as she took her position, with hundreds of observers watching through binoculars and spotting scopes. Media cameras captured every movement as she prepared for the shot that would either validate months of scientific development or end her reputation as a precision marksman. Through her scope, the target appeared impossibly small and distant. The wind effects were visible as heat waves and dust patterns that shifted constantly across her field of view. She controlled her breathing, aligned her crosshairs on the calculated aim point, and gradually increased pressure on the trigger. The shot cracked across the canyon like thunder, echoing off the granite walls in a series of diminishing reports. Through her scope, Loisa watched the bullet's trace as it followed what appeared to be an impossible curved trajectory, rising initially before dropping toward the target through layers of turbulent air. The bullet struck the target plate with a metallic clang that was clearly audible even over the wind noise. For a moment, the crowd was silent as observers confirmed what they had witnessed. Then the canyon erupted in cheers and applause that echoed off the walls like a thunderstorm. "Target hit," announced the range officer, his voice carrying clearly over the public address system. "Sergeant Brock has successfully completed the Blackwater Canyon shot." The celebration was immediate and overwhelming. Military personnel who had been skeptical minutes earlier were now congratulating her and asking for technical explanations. Media representatives rushed to conduct interviews, while civilian shooting experts examined Patterson's equipment with obvious amazement. General Rodriguez approached with an expression of genuine amazement. "Sergeant Brock, in 30 years of military service, I have never witnessed anything like what you just accomplished. This represents a fundamental advancement in precision shooting capabilities." But for Loisa, the moment of triumph was quieter and more personal. As she cleared her rifle and prepared to leave the shooting position, she thought about the journey that had brought her to this point, from the soldier who couldn't calculate a simple crosswind to someone who had just accomplished what military experts considered impossible. Tyler Brooks approached her as the crowd began to disperse. his earlier skepticism replaced by genuine respect. "I owe you an apology," he said simply. "What you did today, ... It changes everything we thought we knew about precision shooting." The Blackwater Canyon shot would become legendary within military circles, but its real significance went beyond the technical achievement. Loisa had proven that scientific methodology could overcome limitations that tradition and experience couldn't address. She had demonstrated that innovation and determination could triumph over seemingly impossible challenges. As she packed up her equipment and prepared to leave the canyon, Loisa realized that her journey was far from over. The success at Blackwater Canyon would open doors to opportunities she couldn't yet imagine, but it had also proven something more important, that the girl who had once been mocked for missing simple targets had become someone capable of redefining what was possible in precision marksmanship. 6 months after Blackwater Canyon, Staff Sergeant Loisa Brock stood before a classroom of advanced instructor candidates at the Army Marksmanship Unit headquarters in Fort Benning, Georgia. The room was filled with the military's most experienced shooting instructors, snipers from elite units, and civilian ballistics experts who had traveled from around the world to learn what was being called the Brock method of environmental shooting. Her life had transformed completely since that impossible shot echoed across the canyon. The video of her Blackwater Canyon success had gone viral within military communities, earning millions of views and sparking international interest in American precision shooting capabilities. Defense contractors had approached her about developing commercial applications for her techniques. Universities had offered research positions. Foreign militaries had requested training exchanges, but Loisa had chosen a different path. Working with Dr. Patterson and the Army's Training Development Command, she had spent the past months creating a comprehensive curriculum that would revolutionize how military snipers approached environmental challenges. The program combined atmospheric science, advanced mathematics, and cutting-edge technology in ways that had never been attempted in military training. "Before we begin today's session," Loisa announced to the assembled instructors, "I want you to forget everything you think you know about wind reading. We're not here to improve traditional techniques. We're here to replace them entirely." The statement would have seemed arrogant coming from almost anyone else, but Loisa's credentials now spoke for themselves. In addition to the Blackwater Canyon achievement, she had successfully completed shots under conditions that other snipers hadn't even attempted. Her techniques had been validated by independent testing and had already been adopted by several special operations units. Private First Class Amanda Foster, one of the first soldiers Loisa had mentored after her own transformation, was now serving as her assistant instructor. Foster had become an expert in the Brock method and represented proof that the techniques could be learned by others, not just their creator. "The fundamental error in traditional wind reading," Loisa continued, "is assuming that environmental conditions are simple enough to estimate accurately. In reality, the atmosphere is a complex dynamic system that requires scientific measurement and mathematical modeling to predict reliably." She clicked to her first slide, which showed a three-dimensional computer model of air movement through various terrain features. The visualization looked more like something from a weather forecasting center than a military training facility. "What you're seeing is real-time atmospheric data from our test range, processed through fluid dynamics software to create a predictive model of wind behavior. This isn't guesswork or intuition. It's engineering applied to marksmanship." Captain Michael Thompson, a Marine Corps sniper instructor, raised his hand. "Sergeant Brock, this appears incredibly complex. How do you expect ordinary soldiers to master these techniques in a reasonable training time frame?" It was a question Loisa had anticipated. The Brock method was undeniably more technical than traditional approaches, requiring soldiers to understand concepts that were typically taught in university-level physics courses. "That's the beauty of systematic methodology," she replied. Once you understand the principles, the applications become predictable. We're not asking soldiers to become meteorologists, but we are giving them tools that work consistently rather than hoping their intuition will develop through trial and error. She demonstrated the portable version of her environmental assessment system, a ruggedized tablet, computer connected to compact atmospheric sensors that could gather and process environmental data in under 2 minutes. The device looked like advanced military communications equipment and was designed to operate reliably in combat conditions. This system provides real-time ballistic solutions based on measured environmental conditions rather than estimated ones, Loisa explained. It removes the guesswork and provides solutions that work regardless of the shooter's experience level or natural intuition. The demonstration that followed was more impressive than any theoretical explanation. Using volunteers from the class, Loisa showed how soldiers with minimal training could achieve precision shots under challenging conditions by following the system's calculations rather than relying on traditional wind reading skills. Sergeant First Class David Chun, her former instructor who had initially been skeptical of her abilities, was among the observers. "This is remarkable," he admitted during a break between training modules. "You've essentially solved the most difficult aspect of precision shooting through applied science." But the real validation came from an unexpected source. General Patricia Rodriguez, who had overseen the Blackwater Canyon competition, arrived unannounced during the afternoon session with a delegation of senior Pentagon officials. "Ladies and gentlemen," General Rodriguez announced, "I'm here to inform you that the techniques being demonstrated today have been selected for immediate implementation across all military sniper training programs. The Brock method will become the new standard for environmental marksmanship training throughout the armed forces." The announcement represented the ultimate vindication of everything Loisa had worked toward. Her scientific approach to wind reading wasn't just being recognized as effective, it was becoming the foundation for how the military would train future generations of precision shooters. After the official visitors departed, Loisa found herself alone with Dr. Patterson in the equipment storage area, surrounded by the instruments and computers that had made their breakthrough possible. "How does it feel?" Patterson asked with a smile. 6 months ago, you were struggling with basic wind reading, and now you're rewriting military training doctrine." Loisa considered the question carefully. "Honestly, it feels like vindication, but not in the way I expected. When I started this journey, I thought success would mean proving my critics wrong. Now I realize it was really about proving something to myself." "What was that?" "That limitations are usually self-imposed. Everyone told me I wasn't naturally gifted at wind reading, and I accepted that as permanent truth. It took failing completely before I was willing to question whether natural talent was really necessary." Patterson nodded thoughtfully. "That's the most important lesson any engineer can learn, that there's usually a solution if you're willing to approach the problem differently." The conversation was interrupted by Amanda Foster, who approached with a tablet displaying news headlines about the new training program. "Sergeant Brock, you might want to see this. The story has been picked up by civilian media." The headlines were more dramatic than Loisa had expected. "Female soldier revolutionizes military shooting. The impossible shot that changed everything, from mockery to military legend." The coverage emphasized not just her technical achievements, but the transformation from struggle to triumph that had made the story compelling to general audiences. "There's something else," Foster continued, showing her a message on the tablet. "We've received training requests from 12 different countries. Apparently, everyone wants to learn the Brock method." Over the following weeks, Loisa found herself at the center of international attention that felt surreal compared to her earlier struggles. Military attaches visited Fort Benning to observe her training methods. Defense publications featured detailed articles about her techniques. She was invited to speak at conferences where audiences included Nobel Prize winners and astronauts. But the most meaningful recognition came from an unexpected source. Tyler Brooks, now serving with the Special Operations Unit, sent her a message that she read during a quiet moment between training sessions. "Loisa, I wanted you to know that your techniques probably saved my life. Last month during a mission in Afghanistan, we had a shot opportunity under conditions that would have been impossible with traditional wind reading methods. Using your calculations, we were able to neutralize the target and extract safely. I owe you an apology for my earlier behavior. But more importantly, I owe you my gratitude. Your work is making a real difference for soldiers in the field." The message reminded Loisa that her achievements went beyond personal vindication or professional recognition. Her scientific approach to marksmanship was providing real advantages to soldiers facing life-and-death situations in combat zones around the world. As she prepared for her next class of instructor candidates, Loisa reflected on the journey that had brought her from ridicule to respect, from failure to fundamental innovation. The transformation hadn't just changed her own life, it had altered how the military approached one of its most challenging technical problems. But perhaps the most important lesson was simpler than any ballistics equation. That persistence, scientific thinking, and willingness to challenge conventional wisdom could overcome obstacles that seemed insurmountable. The girl who couldn't calculate wind had become the woman who redefined what was possible in precision shooting. And in a training facility in Georgia, surrounded by the instruments and equations that had made it all possible, Staff Sergeant Loisa Brock continued teaching the next generation of military marksmen that there was no such thing as an impossible shot, only shots that required better science. The story that had begun with mockery and failure had become a legacy of innovation and achievement that would influence military training for decades to come. Sometimes the greatest victories aren't won on battlefields, but in the quiet moments when someone refuses to accept that their limitations are permanent. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.